Welcome to ActiveMQ Classic Topologies. I'm Heath Kesler, and let's get into it. So today we're going to talk about network of brokers. We're going to take a look at the topologies and how you might set some of these up for high availability, what that means from a producer and consumer standpoint, how to set up the brokers for remote connections, and how to support some of the different properties that might help you get the functionality that you are looking for out of your network of brokers. Here we have a simple network of brokers topology. What we have are two different brokers, a primary and a primary 2, that are connected via TCP. These are done through the activemq.xml file. You just configure it to point to each other. That way they know each other exists and they can now communicate. So when a message is sent through the first producer on primary, it will then get forwarded to primary 2 because there is a waiting consumer. What that basically means, though, is that it is producing to a secondary broker. Now, if you have a local consumer on that same primary, it will prefer that. So what that means is that you got a producer that produces to a local primary that is going to prefer to send that message to a local consumer unless it's either busy or the prefetch is full, which kind of means the same thing. So, whatever. But if you have a producer on the primary 2, he will also prefer a local consumer. So it's trying to find the most efficient path for the messages to be delivered. Now, the caveat here and the thing I want to make clear is that it's doing this if these two consumers are listening on the same queue as these producers are producing, that's when this comes into play. If we are not talking about consumers on the same queue, that's a different scenario, because if this producer here is producing to a queue that only this consumer is interested in, it would obviously just push it to this consumer. So I want to make it clear that these are considered competing consumers on the same queue while these producers are producing to the same queue. And both the primary and primary 2 have that queue on their local because they have a producer and a consumer that are interested in that. So I want to make that clear. So now, if we take a look at what this topology means when a consumer goes down. So if a consumer goes down on primary 2 and the producer on primary 2 continues to produce messages, the great thing about this is that it will just go ahead and start forwarding them to the consumer that's active on the other primary broker, which is a huge benefit from the standpoint that it doesn't just start backing up and your messages are not getting delivered. So what's the next step? What happens if an entire broker goes down? So if we take a look at this, we set up failover connections, and these are all done through the URL, the connection URL. So this takes the producer connection and it starts connecting over to the failover primary broker. Now this is configured in your connection URL. So all of these will reconfigure or re-establish connections to the primary so that they can continue flowing. So as you can see, the messages will continue moving through to the competing consumers after they reconnect to the other primary broker. And then it'll wait for the primary 2 broker to come back online. So what that means is once that primary 2 broker comes back online, everything resets and it comes back to normal. So here the topology is reset, right? The primary 2 comes back online and the primary is established, it reestablishes that TCP connection, and you want your topology to go back to the way it was, right? Because if you don't, all of your producers and all of your consumers will still be attached to the primary. So in this scenario, we want to make sure that the topology knows I want to reset this. So what does that mean? We update the client cluster to true, which basically means when there's a change and there's something going on, it will distribute those changes across the brokers. Then we also tell it, hey, I want to rebalance our clients. So One tells it, hey, I want my clients to understand that the topology has changed. And the rebalance tells it, I want you to reestablish or rebalance my clients when something changes. That way you get that kind of reestablishment of these producers and consumers on the primary two. So the next question is how does all of this happen, right? How does it know what's going on? Well, what ActiveMQ does is it has the concept of advisory messages. And what those really are just messages across and between the two brokers, or in this case, the two brokers. There could be many more, but that's how it understands what each broker has attached. So when a consumer attaches, when a consumer detaches, same thing with producers, an advisory message is broadcast to all the other brokers so that they know that something has changed. And what that means is that allows the other primary or other primaries to know the topology and who's interested in messages so they can forward messages to the appropriate broker when they're required. So let's just say we get a third primary that comes online. And in this case, we want the producer to rebalance. So here you can see that the producer over here is disconnected from the primary and connected to primary 3. He has come online and is connected to primary 2. In this case, it's going to forward any message that it gets down to primary 2, down to the consumer. So it'll follow the path of least resistance to get the message deployed to an active or listening consumer. If that consumer is full and the prefetch is full, it will forward the message onto the primary broker so that the other consumer on the primary could then retrieve the message. As you can see, this gets very, very chatty. So you do have like an ROI on the number of brokers you can put within your infrastructure. Obviously, at some point, the amount of traffic and the amount of chattiness between these brokers starts to outweigh the benefit of having more brokers because you've got too much information having to be exchanged between the brokers and it starts to bog it down. In many cases, the most I've ever configured was 4. I've seen infrastructures that had up to 6, but again, those are very robust. I would never go above that. So if we start looking at some of the high availability topologies for the brokers themselves. So I understand that when we start allowing producers and consumers to attach to other primaries, you do kind of get the concept of high availability, but you're not actually getting true high availability because any messages that were on the primary broker that went down at the time were not, or possibly were not, distributed over to the other broker, which means when the producers and consumers moved over to the other active primary, there were messages missing. So to get a true high availability, you'd actually have to have a primary and a secondary for each grouping of brokers. So in this case, we have a primary one and a secondary one that look for. In this case, we'll do the file-based one, which is a lock on a file. So whichever one comes up and attaches to that file location first and gets lock on that file location, then can instantiate and start up. Same thing with this group over here. You've got primary 2 and secondary 2. Whichever one comes up and they're both linked to the same file location, whoever gets lock is going to be your primary. That then allows you to sit there and that one primary will continue to function until one of them goes down. So here we have a primary 2 goes down. And what does that mean? Well, the secondary 2 takes over the file lock and now starts to function. The amount of time it takes to initialize the connections, as well as reread the KahaDB and reinitialize all of the queues and topics, depends on how many messages you've got, how many queues you've got, how many topics, how many producers. All of that kind of plays into how long it takes to instantiate. It can be a couple of seconds. It could be several minutes. It just kind of depends on how long it takes to reinitialize that KahaDB, as well as reinitialize all of the connections and redistribute the load. All right. Thanks a lot. Thanks for watching. And I hope you subscribe and give a like to the video, especially if you watched it this long. I hope you found it informative. Cheers.